Hey guys, Mr. T here, just doing a quick video on Pearson's correlation coefficient, which will help you with exercise 4C.1 for the 12 General Maths textbook. So, if you recall, our very last lesson was talking about correlations, and we only spoke about correlations in terms of 5 things: their direction, linearity, strength, presence of outliers, and causality. So, if you acknowledge, these are just words. We haven't introduced any mathematical concepts to this either. We just said the direction was positive or negative. It looked like a line for linearity. Strength was moderate, weak, or strong. Outliers were either there or not, and we used logic to decide whether there was a causal relationship. So, no maths yet. But obviously, this is a math subject, so we need to introduce some maths. So the first indicator of a correlation that we deal with is Pearson's correlation coefficient, which is represented by a lowercase r. Now, this coefficient, which is literally just a number, but represented by the variable r, has some very specific properties. It's a number that ranges between -1 to +1. The sign of r indicates the direction of the correlation, so now we have a number representing direction. If the sign is negative, then the correlation goes down to the right, so like this, negative correlation here. And if the sign of r is positive, it's a positive correlation, so it goes up to the right, like this. Then the size of r, the size of Pearson's correlation coefficient, which, because it ranges from -1 to +1, the biggest it can be is 1 or -1. So the size of r, being how close it is to 1, indicates the strength of the correlation. So your best bet is to summarize Pearson's correlation coefficient, the description of it, by using the table in your textbook on page 84. This is what that table looks like. So as you can see, if r is 1, the sign of r is positive, meaning a positive correlation, and being exactly 1 means it's a perfect positive correlation, which means that it's an incredibly strong correlation. And as you can see, as the strength goes down, so if r is between 0.95 and 1, then we'd only claim it to be very strong. Between 0.87 and 0.95, then it's only strong, and down we go. Okay, and the same goes for negative, which brings me to the idea that for your notes sheet, you should only need to draw half of this table below for it to make sense, because as you see, the description, perfect for 1, very strong for 0.95 to 1. These are all the same descriptions for the strength. The only difference is the direction. So don't waste space on your cheat sheet by drawing the whole table. Only draw one side, and then understand in your head that if it's a negative sign, then it's going down to the right. Okay? So, clearly using r to indicate correlation is more mathematical than just saying words like strong, weak, moderate, etc. But you need to be able to find r. R is one of the many statistics you need to find using your graphics calculator after you've entered the data into the calculator. So this is another topic where you hammer the graphics calculator. Last time in finance we hammered TVM solver. Now you're hammering something called statistics here. So how do we enter data? In this topic, you're going to be asked to find statistics about data sets. You're going to use your graphics calculator to find those stats, but that can only be done when you enter data into the calculator. So how do you enter data into your calculator? Step 1 is not even entering the data. There's something that you need to do, which is to press second, which is the blue options, and press 0 to go to catalog, which you see in blue. Then you're going to scroll down to diagnostic on. You could do this using the arrows. Okay, so I'll show you. It's annoying because this Samsung thing. I could scroll down to diagnostic on by using the arrows, but that took a while. If you want to play smart about it, you can go to this x to the -1. You can see above it is D in green. I can quickly skip down to the D entries by pressing that, because that's the D button, and then scroll down only a little bit to get to diagnostic on. Okay. Once you've got to diagnostic on, you press enter, and it says, do you want the diagnostics on? It should say question mark, but it doesn't. And then you press enter again. It says done, which means I've turned diagnostics on. Now, because you're doing statistics as a topic, and diagnostic on only turns off if your calculator resets. If you know that you've already done this diagnostic on while using the calculator, you can skip step 1. I only put it as step 1 because you might as well just turn it on all the time, okay? But if you get the hang of all this and you know that you've already turned it on, then don't waste a step there. So now, how do we enter data? You press stat, select one edit, as you can see there, and you will see a table with columns L1, L2, L3, etc. that goes on. Okay, it's got a bunch of L's, which are lists. And what you do is you enter your data into the lists. Please get into the habit of entering your X data into L1 and your Y data, the dependent variable, into L2, and you press enter after every number. So let's enter some data. Let's say it's 1, 2, this is the X data, 3, 4, 5. And let's enter the Y data. Let's make it a very perfect correlation. So as X is 1, Y is also 1. As X is 2, Y is also 2. So this would be a perfectly diagonal straight line. So we should know that Pearson's correlation coefficient is going to be exactly 1 if we find it for this data, okay? One thing to add here is if you ever need to clear a whole column of numbers to start over, select the heading, so L2, and press clear. And then when it's going, okay, what do you want in L2? You press enter and it'll clear it. Do not press, I just did it. I cleared it, so I'll enter the data again. So 1, 2, 3, 4, 5. If you accidentally press delete on this, right? If you press delete, it deletes the whole column. See, I've got no L2 anymore. And that can freak you out because you're not experts or anything. So just to show you how you can get it back, you go second delete, which says insert, and it's asking which list do you want, and I'll go to L2 in blue here, second L2. It brings it back, but just to be safe, if you want to clear a column really quickly without having to delete every single one, you highlight what do you want in L2, press enter, and it clears it, okay? 1, 2, 3, 4, 5. Put that back. So how do we find Pearson's correlation coefficient? So step 1, ensure you've entered your X and Y data. We have. Press stat. Press the stat button. Use the arrow to select the calc menu. So you can see calc there. Press to the right. Select 4 linreg AX plus B. So that stands for linear regression. So this Samsung keeps skipping down. Your calculator is not going to do that. It's just my Samsung having a heart attack here. Skip to linreg AX plus B. Please do not select A plus BX. That'll be confusing for you. Number 4, linreg. And what you're asking the calculator to do is, can you apply linear regression, which is fitting a line relationship to the data that you put into stat edit. Okay? So you press enter there. You tell the calculator which lists your X and Y data in, and I told you to get into good habit of putting your X data into list 1, Y data into list 2. That's why you form that habit. And then you select calculate and you press enter, and there it tells you. A list of statistics appear assuming you're fitting the data to a linear relationship. So the heading there, linreg, is telling you that you tried to apply a linear regression, which is fitting a line relationship. This y is equal to ax plus b indicates that the line it tried to fit to the data has the equation in slope-intercept form, which you were taught in topic 2. A is the slope of the line because it's what's in front of x, and that's telling you the slope is 1. So as you go to the right once, you go up once. B is the y-intercept of the line, which goes through 0. R squared is something we're going to talk about next exercise. And here is Pearson's correlation coefficient, R, which we said was going to be 1, and you can see is 1. Why? Because it's got a positive direction, positive 1, and the strength is perfect because, as you can see from the data, it's 1 to 1, 2 to 2, 3 to 3, 4 to 4, and 5 to 5. So that is how you find Pearson's correlation coefficient and also how you enter the data. So let's do an example here. The botanical gardens have been trying a new chemical to control the number of beetles infesting their plants. The results are shown in this table. Draw a scatter plot for the data. So for a scatter plot, you need to decide what the explanatory or the independent variable is. Beetles aren't going to affect the amount of chemical. However, the amount of chemical is going to affect the number of surviving beetles. So you can see when there's a low amount of chemical applied, there's heaps of beetles. When there's a high amount of chemical applied, there's less beetles. So quantity of chemical should be on the x-axis. And number of beetles should be on the y-axis. Let's draw it. 2 to 11. When there's 2 grams of chemical, we have... Oh, let me draw. Come on, draw. 2 to 11, so that's going to be there. 5, which is there, to 6. 5 to 6. 6 to 4. 3 to 6. So that's a little lower than all the other dots. Draw an arrow there. Redraw that. What was that one? 6 to 4. And 9 grams to 3. So here you can see it's not a perfect correlation. Yep, I've drawn that. Scatter plot. Determine Pearson's correlation coefficient. So we need to enter the data. So how do I clear? Because I've got data existing. Clear, enter. Clear, enter. So our X data in list 1, 2, 5, 6, 3, 9, 11, 6, 4, 6, 3. How do we find Pearson's correlation coefficient? Make sure you've entered the data. Press Stat, select Calc, select for lin reg. Make sure the data's in where it's supposed to be, list 1, list 2, calculate. That tells us that using the graphics calculator, R equals negative 0.886 to 2dp. And describe the correlation between the quantity of chemical and the number of surviving lawn beetles according to R. The correlation is... So now we look at the table. It's 0.86, so it's between 0.7 and 0.87, so it's a moderate negative correlation. Moderate negative correlation. You could also comment on that. It looks linear with a possible outlier, because this one sits kind of low. That one's 3.6. Okay, so that's an example of entering data, drawing a little scatter plot there. Don't bother doing what the textbook says and doing it on your calculator, because that would be a waste of time in an exam if they ask you to draw a graph on your calculator. How do you show evidence of that? Okay, you're going to be drawing them yourself. Question B, determine Pearson's correlation coefficient. I showed you how to do that. Enter the data, press Stat, select Calc again, and linreg. And then C, describe the correlation. Well, we have a numerical way of describing correlations, this coefficient, okay? And this table here is how you do it. So hopefully that helps you out, and I will see you on the next video.